Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSC, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. A series of lectures cover about mobile and pervasive computing. This lecture series cover cellular wireless networks, GSM, that is Global System for Mobile Communication, GSM architecture, the protocols used in GSM, the connection establishment and frequency allocation, GSM handover, security in GSM, and the General Packet Radio Service, that is GPRS. The content of today's lecture is about providing the security to the GSM users or GSM data. We all know that the GSM users are connected with the GSM network through the radio link. So, the users are sending and receiving the information like text, image, voice over the air interface. So, the air interface or the radio link is highly vulnerable to various kind of security issues. So, the GSM network has to provide some security to the data transmission. We will learn all the security issues and methods one by one. The GSM network provides the security to the mobile users. To achieve the security or to handle the security issues, the GSM stores the information related to the security in two locations. So, one is authentication center, that is AUC, and the second one is the SIM card, that is the subscriber identity module. This is the overall functional architecture of the GSM network. Now, the mobile stations or the users are connected with the base transceiver station. So, the interface is the radio interface. Now, through the radio interface, the mobile users are connected with the rest of the network. Here we can identify the authentication center. Now, the authentication center is located in the operation subsystem layer or OSS layer, and in the network and switching subsystem we have visitor location register, home location register, and mobile switching center. To provide the security for mobile users, authentication center, visitor location register, home location register, and mobile switching center and SIM card, they all the components of the GSM are involving in the provision of security. The authentication center plays the vital role in the provision of GSM security. We will learn it now. The radio interface and mobile stations are particularly vulnerable. The users are connected with the cell phone tower through the radio link. So, that radio link is highly vulnerable because we cannot put the boundary to the radio signals. It can be penetrated as like unlike the guided media, we cannot guide the signals, radio signals properly in a particular direction. So, it will keep on propagating through various directions. So, other hackers may hack the information. So they are specifying that the radio link is highly vulnerable. So the GSM provides separate authentication center, or it defines the separated authentication center that protects the identity and data transmission. Now the authentication center of the GSM network provides the security by hiding the real identity of the user. So the authentication center contains various kind of algorithms for authentication. So we have algorithm 3, algorithm 5 and algorithm 8 to provide the security in GSM. So authentication center contains the keys for encryption and it generates the values needed for users authentication in the HLR. The users has to be authenticated. All the users cannot be let to access the facilities of GSM. So only the valid users should access the GSM services. So first of all, the users has to be authenticated. After authenticating the users, the GSM network should provide the encryption mechanism. So we will learn what is an authentication and how the encryption is achieved in the lecture. So the authentication center in fact is situated in a special protected part of home location register. So sometimes the GSM network can have the separate space for authentication center, or in sometimes the home location register is used to accommodate the authentication center. So far we have learned what are all the informations are stored with the authentication center. Let us learn about the SIM card or subscriber identity module. The SIM card stores personal and secret data that is protected using the PIN. So PIN is nothing but personal identification number. Using the PIN number, unauthorized access to these kind of secret informations can be denied. So even the valid users are applying the PIN number wrongly for more than 3 times, the SIM card will be blocked. Then the user has to contact the service providers to get the PUK code. So PUK code, that is personal unblocking code. So using that PUK code, a user can unblock the SIM. If the user is trying with the wrong PUK code for more than 10 times, the SIM card will be permanently blocked. Then the user has to get the new SIM card. So providing the security to the secret information is achieved through PIN code in the SIM card. So SIM code stores several kind of personal informations. They include secret key, that is referred as KI. This secret key is used for both authentication as well as encryption. So this key is shared by many algorithms. So far we have learned what are all the informations are used and where they are stored in the GSM network for providing the GSM security. The security services offered by the GSM are listed below. They are access control and authentication, confidentiality, anonymity. Access control and authentication. This is the mandatory service for any kind of communication system. For example, if we are accessing our Yahoo mail server, we have to be authenticated, or the Yahoo server will authenticate the right users. So in general we used to give the username and password. If the username and password are correct, then we can access the information, else our request will be rejected. So the malicious users cannot access the data. So that is the main intention of providing the access control and the authentication. So at the first step, the authentication of the valid user for the SIM card is performed. The user needs a secret PIN to access the SIM. The first level, the GSM provides the access control to the SIM card level. So as we already learned, the SIM card access can be restricted using the PIN number. So the malicious users cannot access the SIM card using the PIN number. So the next step is the subscriber authentication is performed. So this step is based on the challenge response scheme. So GSM offers the facility like challenge response access mechanism scheme that we will learn in the lecture. This diagram is about the flow of control messages in mobile terminated call as well as mobile originated call. So here we can note that the BTS or the base transceiver station is sending the authentication request. So this is nothing but the authentication request generated by the BTS. Now the user or the mobile station has to send back the authentication response to the BTS. So, based on the response, the chippering command or the encryption is performed. So, here also in mobile originated call also the authentication and the chippering command are same. So, the idea is to identify the valid users. After identifying the valid users, the data has to be protected using the cryptographic mechanisms. Next level of providing the security in GSM is confidentiality. After proper authentication, the user either can send the information to the network or they can receive the information from the network. So, they are sending and receiving the information through the air medium. So, that information which is transmitted over the air medium has to be protected. To protect the information, the GSM is offering the concept of encryption and decryption. All user related data is encrypted. After authentication, the BTS and MS apply encryption to voice, data and signaling. Now, the encryption can be applied to the user data, that includes voice. The calls are encrypted and the SMS, the messages are encrypted. Sometimes the control messages, they are also encrypted. This is known as the confidentiality. And one more thing is, the confidentiality is provided between the mobile station and the cell phone tower, not between the end to end system. So, the user should understand this. So, in the case of GSM network, the encryption is applied only between the mobile station till to the BTS, that is the base transceiver station. So, the end user, end to end means providing the security between the mobile station, that is from the source to the final destination or the last mobile station or some other fixed stations. So, users are authenticated and data is encrypted. Now, the third important issue is anonymity. We know that the users are connected through the air medium or air interface. Now, showing or exposing the real identity of the user over the air interface is highly dangerous, because anyone can hack the data. So, to avoid all kind of security problems, the real identity of a mobile user should not be exposed or transmitted over the air interface. So, to avoid this problem, the GSM is offering the temporary identity. Hiding the real identity of the GSM user is known as anonymity. Now, the users are identified by their IMSI number. This IMSI number is the real identity. Now, it is dangerous to show the real identity over the air interface. Hence, the GSM hides the real identity in the air medium. So, to provide the security, first the users are authenticated and the information to be transmitted is encrypted, and then the anonymity is applied. So, instead of transferring the real identity, the temporary mobile subscriber identity or TMSI number is used. So, it is the duty of the visitor location register to assign the TMSI number. So, the users can move from one location to another location. The moment the new user is located or entered into the new visitor location register, now it is the duty of the VLR to assign the new TMSI number, and the visitor location register can change the TMSI number at any time. So far we have learned about the security issues and various kind of mechanisms used to provide the security in GSM network. Let us have a short break. After the break, we shall continue our discussion. Welcome back. Before the break, we were discussing about providing authentication and encryption and anonymity and all. Now, let us learn about the algorithms used in the GSM network to achieve all kind of securities. Basically, three algorithms are specified in the GSM standard to provide the security. They are algorithm A3, algorithm A5 and algorithm A8. In short, they are referred as A3, A5 and A8. Now, A3 is used for authentication, A5 is used for encryption, A8 is used for generation of Chipper key. So in the GSM standard, only the algorithm A5 was publicly available. Till 1998, the algorithm A3 and A8 were secret and standardized with the open interfaces. Now the network providers can use stronger algorithms for authentication. It is purely depends on the network service provider to strengthen their algorithms for providing the security. Now the GSM adds some flexibility, that is the users can add the security or the users can provide the security between the end-to-end systems. So along with the GSM security, now the users can apply their own security mechanisms. Even through the network they can use their own encryption and decryption methods. So algorithm A3 and A8 are located on the SIM as well as in the authentication center, and A5 is implemented in the devices that has to be identical for all providers. So here we should understand one thing, both the algorithm A3 as well as A8 can be specific to the service providers, but in case of A5 that should be common for all the devices. So let us learn what is an authentication and how it is performed. So this diagram is about a simple authentication method. Here, to access our Windows services, the users has to provide their username and password. So if the username and password is correct, we can access the session, or our request will be rejected. So this is the base for providing the GSM authentication service. Before an user can access any kind of service, first the user has to be authenticated. So the malicious user should not access any facility. So the moment if we are making a call to your friend, immediately you will be authenticated. Your SIM card will be authenticated. If the requested services are already subscribed, then the network will do the authentication and it will offer the service. If the user is not authenticated, then the request generated by the mobile station will be rejected immediately. Before a subscriber can use any service from the GSM network, that user has to be authenticated. Now the authentication is based on the SIM card. As we learned, the SIM card stores the individual authentication key, that is referred as KI, and the user identification, IMSI. We should remember that the IMSI is the real identity, and the algorithm A3. The authentication uses challenge response method. So we will learn what is a challenge and what is the response for the challenge now. The access control or the AC that generates the random number, that is referred as RAND or RAND as a challenge. Now the SIM card within the mobile station answers with the SRES, that is referred as signed response as the response. The authentication center will generate the RAND as a challenge. For the challenge, the SIM card has to answer properly. The authentication performs the basic generation of random values, signed responses, that is SRES, and the Chipper keys, that is KC for each IMSI. Then it forwards the information to the HLR. So after generating all kind of information, this information has to be sent to the home location register. Now the current VLR requests the appropriate values for RAND, SRES and KC from the home location register. So the moment the mobile station is enter into the new visitor location register, now the visitor location register will request the corresponding home location register to provide the RAND and SRES and the Chipper key. For authentication, the VLR sends the random value to the SIM card. So both sides, that is the network as well as the subscriber module, perform the same operation with the RAND and the key called KI using the algorithm A3. For providing the authentication, both the network as well as the subscriber identity module have to execute the algorithm A3 with the values of RAND as well as the KC. Now the mobile station sends back the SRES generated by the SIM card. Now the VLR can now compare both the values. So after receiving the SRES from the mobile station, the visitor location register has to compare both the values. If both the values are equal, the request of the mobile station will be accepted. If they are not equal, the mobile station's request will be rejected immediately. Let us map our discussion with the diagram. So this is about providing the authentication. Here this is the mobile network and this is the SIM card. SIM card is fitted with the mobile station or user device. Now just to assume that the mobile station is entering into the new visitor location register. So the authentication center is now generating the RAND and that RAND is given to the SIM card, and it also generates the identification key referred as KI. Now A3 is used in the authentication center, and using the values of KI as well as RAND value, the network will generate the SRES. The SRES generated by the network is marked with a star symbol. Now using the same algorithm, we should remember that the algorithm is already available with the SIM card. Now using the same algorithm, the SIM card should be able to generate the SRES using the RAND as well as the identification key KI. Now both the SRES as well as SRES star is given to the visitor location register. Generally it is under the control of mobile switching center. If both the values are equal, the SIM card will be accepted, or the SIM card or the request from the mobile station will be rejected. In this manner the GSM is achieving the authentication. We have learned how the users are authenticated in the GSM network. Now after authenticating the user, the information has to be protected. As we are transmitting the information over the radio medium, the data should be protected properly. So the protecting the mechanism over the network is referred in general as cryptographic mechanism. So what is a cryptography? So encrypting and decrypting the data for providing the security is known as cryptography. So here this is the source device. The source user is sending some information and the information is encrypted. So encrypted data is nothing but protected. So the receiver or the end user has to use the same key, or in some situations some different key, to open the encrypted data. So if sometimes if the malicious users are trying to access the information without the proper key, they cannot access the data. Even though they can receive the information, they will not be able to open the data properly. So this is the logic behind the encryption as well as decryption. Let us learn how the encryption and decryption is applied in the GSM network. To ensure the privacy, all messages are encrypted in the GSM over the air interface. So here all messages include text message, images and voice, etc. After authentication, the mobile station and the BSS can start using the encryption by applying the Cipher key KC. Now the KC is generated using the individual key KI and random value applying by the A8. For the purpose of encryption, the random value as well as the KI is used. The user should keep in this mind. SIM in the MS and the network both calculate the same KC based on the random value, that is RAND. The key KC itself is not transmitted over the air interface. So once again, the Cipher key or KC is not transmitted over the air interface. Let us map our discussion in the diagram. So here this is the mobile network part, this is the mobile station with the SIM card. Now the algorithm A8 is used in the authentication center. KI and RAND are the two values taken by the algorithm A8. So using these two values, now the algorithm A8 is generating the KC, and the SIM card is provided with the RAND value. Now using the same A8, the SIM card should be able to generate the KC. So using the KC, the data is encrypted in both the directions. So now you can understand the A5. So A5 is an algorithm used in the mobile station as well as in the network part. So using the A5 algorithm, the network as well as the SIM card is encrypting the data. Mobile station and a base transceiver station can now encrypt and decrypt the data using the algorithm that is known as A5 and the Cipher key KC. So far we have learned how the GSM is offering the services of security services to its users. So the GSM network is providing the authentication service and anonymity service as well as encryption decryption method. Now actually the providing the encryption and decryption method in GSM network is derived from the general OSI layer architecture. So in the basic of ISO OSI layer, that is International Standard Organizations is defining a open system interconnection. So now in the OSI we have 7 layers. They are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and last one is physical layer. Now the layer 2, that is the presentation layer, is responsible for making all kind of security issues. So the application data or application layer generates the data. Through the application layer the users are interacting with the network. So this is common for all kind of communication network. So through the application layer now users are making the connection to the network. In case of mobile station, now we are using some browsers in mobile phone, or we are typing the messages in the provided space. These are all the application layers. Now through the application layer or application protocol, the users are communicating with the network. Once the users are authenticated, it is a duty of the presentation layer in OSI architecture to provide the encryption. So the user data is readable before encryption. So once the data is encrypted using the Cipher key, the data cannot be read by the malicious or unintended users. Though they can hack the information, they will not be able to interpret the information properly. So that is the beauty of using the encryption. In the receiver side, the receivers will receive the information. If they are the right or valid receivers, they know the real key, how to open the information, they know about that. So using that key they can interpret the data in the reverse manner. So applying the Cipher key once again to the encrypted data and opening that into the original data is referred as decryption. So encryption is done at the source side and decryption is achieved in the receiver side. Now many kind of algorithms we have to provide the encryption as well as the decryption. Many methods are also used. So very famous two methods or mechanisms are public key encryption and private key encryption. So in the public key encryption, both the sender and user can use the same key. So in private key information or in private key encryption, using the private key, the source will encrypt his own data, and that encrypted data is transmitted over any medium. It may be wired or wireless. In the context of GSM, it is wireless medium. And at the receiver side, the receiver will receive that information, and using his own or his private key, he can decrypt that information. So encryption and decryption is basically applied with the help of presentation layer. So in the GSM network also we have the presentation layer. So that is nothing but that is implemented in the browser and all. So using that presentation layer, both the encryption and decryption is achieved. So providing the encryption and decryption at the link layer level also possible. So we can even protect the information in all the levels. So we can provide the security in the application data level, or in sometimes we can provide the security in the link layer also. So the data link layer can be using the security mechanisms. Let us summarize what you have learned. Global system for mobile communication stores several confidential information in the SIM card and authentication center. The global system for mobile communication users can use a secret PIN code to access the SIM card. The GSM authenticates the valid users before they access the services from the network. The GSM secure the data transmission using the cryptographic method. Let us pose some questions for our understanding. Why does the GSM hide the real identity of an user? Differentiate IMSI and TMSI numbers. What is challenge response based authentication in GSM? Does GSM offer an end-to-end confidentiality? Identify the role of authentication center in GSM security. With this we conclude today's lecture. We shall discuss about the general packet radio services in the next lectures. Thank you.